I am Andrea Cuadra. I am a PhD candidate at Cornell Tech in the Information Science Department. Today I will be talking about a paper I first authored. It's called My Bad, Repairing Intelligent Voice Assistant Errors Improves Interaction. My co-authors are Shuran, Hansol, Jason, and Wendy. In a nutshell, at the end of this talk, you will be able to understand how we came to the following findings. The first one is the existence of repair made participants feel successful, regardless of whether repair was needed or not. And on the flip side, when no repair was made in the presence of a mistake, participants felt frustrated. The second finding is that unnecessary repair made the agent seem anxious and produced a drop in how successful participants felt. But the drop was not as large as the amount of frustration caused by no repair. And finally, we will discuss certain themes that emerged in the study, including helpfulness, frustration, improvement in human understanding, empathy, efficiency, and creepiness. In the study, we ran the study with 101 participants in a lab setting. So when humans talk to each other, we don't only talk in words. We also use other forms of communications, like nonverbal communications such as facial expressions. For example, if I said something and I see in your face that your reaction is not what I anticipated based on what I said, I might stop and ask you what you heard to confirm that you heard what I intended for you to hear. And this sort of action of interrupting the flow of a conversation to ensure that there wasn't an error to repair the error is called self-repair. However, machines don't perform self-repair at the moment. And we wondered, what if computers could detect errors in conversation from their users' facial expressions and repair them? If this was the case, how would self-repair be perceived? Would people want it? What if it happened when it was not needed? In order to answer these questions, we brought participants to the lab and gave them a research scenario. Imagine you're in a car about to start driving to a friend's house. You're going to use a voice assistant to help you accomplish a few tasks. Imagine Alexa, the voice assistant you're using, has the ability to see your reactions through a camera. Just note, in this talk you will see videos from participants, and I just think it's important to mention that all participants consented to having their interactions be video and audio recorded and publicly shared for the purpose of this research. All right, so when participants came to the lab, they were given the scenario and then they experienced one of the following 4 conditions. The first one was a control condition, where there were no mistakes and no repair. The second one, below the control condition on the lower left side of the screen, they had mistakes but no repair. This is what usually happens right now if there's an error in conversation with a machine. The machine does not attempt to repair that error. It's on the human to try to make try to fix whatever went wrong. Then on the right, we have the more experimental, like the intervention conditions. So the first one is the overcorrection condition, where the agent detected an error that wasn't there. So it made an unnecessary repair. And finally, the correction condition is what we imagine being the ideal condition if a mistake is made, where the error is detected and successfully repaired. And this is what one of the tasks looked like for each condition.
Alexa, play relaxing music.
Playing relaxing music.
Play relaxing music.
Playing heavy metal.
Play relaxing music.
Playing calm, relaxing ambient by Devis Rec. You don't seem pleased. Did I get that wrong?
You got it right, actually.
Play relaxing music.
Playing heavy metal. You don't seem pleased. Did I get that wrong?
I want to hear relaxing music.
Oh, I see. Playing calm, relaxing ambient by Depa's-Rec.
So this was one of 4 tasks participant had to perform in the interaction. And after this interaction was completed, they were asked to complete a survey with 22 questions about their perceptions of the voice agent and about how the voice agent made them feel. Then we had data from 101 participants on 22 different factors that we had to figure out a way to summarize and make sense of. So we used principal component analysis to reduce the dimensions of this data. And we're able to identify 2 components that could explain approximately 56% of the variation in our data together. So the first component is the one on the horizontal axis. It ranges from frustrated to successful, and it's about how the voice agent made the participant feel. The second component, this component accounted for about 46% of the data. The second component on the left, on the vertical axis, is how the voice agent was perceived, and it ranges from anxious to calm. And if we look at the scatter plot, the dots on the graph are the answers, the answers per participant. So wherever a participant fell for those 2 axes. And the colors represent the condition, the square represents the means for the condition. So if we look at this graph here on the left, it seems to be like an isolated thing on the left side, an isolated point on the left side of this graph. And this is the undercorrection condition where participants felt frustrated. In the other conditions, they seem to feel closer to successful. Then similarly, if we look at it from top to bottom, we see that the green square here is closer to anxious. This is for the overcorrection condition where the voice agent made unnecessary repair. So if we dive deeper into each of the components, we can see how this data was spread in these box plots. So first on the left, we have the Likert scale that was given to the participants in the survey, ranging from disagree strongly to agree strongly. Then here we see the conditions without repair, the control condition on the top, the undercorrection condition in the bottom. And on the right, we see the conditions with repair. If you see here, overall, all the conditions, except the one that did not have repair, fell at or over the neither agree nor disagree line, the medians for the condition. So this led us to infer that the existence of repair made participants feel successful, regardless of whether the repair was needed or not. On the flip side, when no repair was made in the presence of a mistake, participants felt frustrated. Then if we look at the graph, at the box plot for the other component about how the agent was perceived, from disagree strongly with the agent being perceived as calm to agree strongly with the agent being perceived as calm, we see that the only median that falls below the neither agree nor disagree line is for the overcorrection condition. And with this, we can conclude that unnecessary repair made the agent seem anxious and produced a drop in how successful participants felt. But the drop was not as large as the amount of frustration caused by no repair. This is what participants said after they had interacted with the voice assistant in their condition.
It did exactly what I told it to do, and it was pretty easy.
I just was trying to perform a few tasks, but it seemed like Alexa didn't want to cooperate and didn't get far with it.
Every time she got it right, like she did what she was supposed to do, but since I didn't respond or give her like maybe a keyword like good or something, she said like, did I do it wrong? Which was like slightly annoying, but it wasn't, like the end all. Like it still could be useful.
It had a good ability to see my expressions, because like usually you have to say yes or no after something, and like she immediately noticed that I wasn't happy.
It doesn't make me feel like I'm talking to a machine. it feels to me like I'm interacting with somebody who can actually observe how I feel and like try to identify any mistakes it makes.
So in these videos, we see snippets of the themes that emerged from our interviews: helpfulness, frustration/annoyance, improvement in understanding, empathy. And there were some themes that did not come up in the videos but were present in the rest of the interviews. This included the talk about how efficient or fast the voice agent was. So we heard things on both ends. Either this voice assistant was efficient or a lot faster versus it would add extra work. And finally, we also noticed some participants raised concerns about the perception of the voice assistant being creepy. So, for example, one participant said it would be creepy at first, but eventually people would get used to it if it was actually better. And so with these findings, with these themes and the things I've presented, we can move forward to discuss our findings and map them to design guidelines. The first finding is that assessment of self-repair performance is influenced by expediency, which means that self-repair can backfire if time or accuracy is of the essence. So it is important that we consider the context in which a voice assistant will be used before we deem it appropriate to build in self-repair to that voice assistant. For example, in games or educational settings, it might make sense to have a voice assistant that performs self-repair and is more personable. Then self-repair makes agents seem helpful but also creepy, which means that the social and emotional benefits of self-repair in interaction need to be balanced against the creepiness of the monitoring and modeling needed to make self-repair possible. And finally, we noticed that participants who experienced mistakes were more likely to appreciate self-repair. And this takes us to the final design guideline, which is that self-repair helps to indicate care and promote user engagement. With this, we can discuss ethical considerations. First, interfaces that use computer vision in this way could normalize surveillance. We are already in a place where we're becoming used to having machines listen to us all the time, and the implication of this is that machines would also be looking at us. And just a quick note, these topics are discussed in a lot more depth in the paper. Second, the interfaces that perform human mimetic interaction patterns blur the distinction between human and machines. And finally, the use of speech in conversational repair can reinforce stereotypical gender norms. All right, so with that, I would like to take a moment to thank Alexa, Malte, Sue, Paul, Elon, Joe Fish, and the Mozilla Foundation for their considerable help and support throughout the study. Thank you for listening, and please reach out if you have any questions about my research.